Good morning, friends. Here I am making your video for Algebra 1, Chapter 7 review. Um, we're going to dive right in. I want to remind you of two things. You're going to use your calculator to graph for a 7.1 at least. So when you go to your y equals, you're going to notice that the last thing we did was inequalities. Your signs are not in the right place. So make sure you go back out and you go to, for Laurel and for Carrie, you're looking for this instead of this or this. Okay. For Jonathan, you're looking for just a simple line. And I don't remember if it looks that direction or this direction. I don't have that calculator. But you're just looking for one simple line that looks like this in your little thing. It's just a line. I'm pretty sure it points that way. Okay. That would give you the equality instead of inequality. Let's go into this really fast. I changed the first equation a little bit just to remind you a few things. First of all, you can't graph until you get to y equals mx plus b. Okay, so I have y plus x equals -2. The book has it set up correctly. I'm going to minus x. I'm going to minus, oh no, this is, it is minus in here, sorry. I'm going to plus x, I'm going to plus x. This becomes y equals x minus 2. And it is in the right shape now. The second one is already in the right shape. Y equals -3x plus 2. I'm going to go to my y equals. I'm going to put -3x plus 2 in case you're wondering. My first equation is in. Here it is. You're looking for that equal sign. I want to let it focus so you can see it. Okay, make sure you don't have a greater than or equal to. And Jonathan, if I can do this, let me see. You are looking for that line. See right in front of y equals, it's a line. That's what you're looking for. And then I'm going to do some 6. And here's my beautiful graph, just like in the book. And I can immediately tell that x is, let me look at that graph. X is 1 and y is -1. That's my solution to my equation. X equals 1, y equals -1. Please remember that I need more than just the graph. I actually need, if I would have to graph it, it kind of looks like this. That was really bad, but it's okay. I need you to tell me what that point is. We need to define the point, okay? So this is how we do it. You bring equation to this form, then you go to y equals, you put in your two equations, zoom 6, get your graph. Please transcribe it. Actually, no. For 7.1, yeah, transcribe the graph. I need to see the graph drawn, and then tell me what is x and what is y. As a quick reminder, if you don't remember how to get there and you can't read them correctly, please remember that we can play with the little, we can make that little thing move around and get it to where we need it to be. Right? This is what I mean. The little flickery thingy. And then you can round. All of your test questions have full answers, not decimals. So round and you're good to go. We're on 475. I need you to take a break and I need you to work 5 and 7. 5 and 7. And then come back and I'll have the graphs up here. Let's check and make sure you got them right. 5 and 7, 475. Go ahead and pause. Okay, guys, here are your two graphs. I'm going to get out of the way. And these are your solutions for 5. X is 2, y is -5. It was already set up for you. All you had to do is get the numbers out. For the second one, I actually solved it. The first equation was easy. You move the x on the other side. Y equals -x plus 3. For your second equation, that -y, remember, put a -1 in front of it because it changes all of your signs. You end up with y equals x minus 5. If you need to, go ahead and pause the video and see if what you have is what I have, or see where you went wrong. Your final solution is x equals 4 and y equals -1. We're going to move on into chapter 7.2, which is we've learned how to solve equations by substitution. That's just our new thing. I'm going to keep that y equals mx plus b there just because we're going to use it later. And the equation we're looking for is 3x plus y. 3x plus y equals -9. And y equals 5x plus 7. This is the example we're working with. It is already separated for you. I am going to change my mind and write this as -5x plus y equals, was it -7? No, equals 7. The reason I'm doing this is because I want to remind you how we get to how to solve by substitution. I didn't write it. This is 2. And that is by isolating or by defining one of our variables. Both of these work. It doesn't matter which one. I have a y alone here and I have a y alone here. I'm going to do the opposite of the book and I'm going to isolate this one. I'm going to say minus 3x minus 3x. Actually, no, don't do it that way. And here's why. You don't want to work with negative numbers unless you have to, right? We went through this over and over again. If I just plus by 5x on the other side, I end up with y equals 5x plus 7, which makes this all positive numbers. I now have my y very well defined. I can take this and plug it in my first equation. This becomes 3x plus, please initially use parentheses every single time, 5x plus 7 equals -9. I want to make sure that I have the right signs. I do. We're going to go ahead and take the parentheses out because that's a plus. Had this been a minus, I would have asked you to put a 1 and distribute. 3x, 5x, 9x plus 7 equals -9, minus 7 minus 7, 9x equals, is this a decimal? I am so confused about this. Oh, we're getting there. That's a 9. That's why I got confused. This is 8. 3 plus 5 is 8, correct? Not 9. This is 8x equals -16 divided by 8. X equals -2. We got our x out. X equals -2. I can now take this and put it into my initial equation just to get y out. Y equals 5 times x, which is -2 plus 7, -10 plus 7. Y equals -3. X equals -2, y equals -3. Quick reminder. What do you need to do? Isolate one variable or define one. That's very easy. Now you will always pick the one that doesn't have any other number in front of it. Move everything over. And then we substitute it. Once we define it, we go to the second equation. We replace it. There's a number in front of that y. Please remember we distribute. And then once you solve for one variable, you plug into your original one and find your second variable. I am going to let you pause. And again, we're just going to use 2 of each examples. I'm going to let you go ahead and work 8 and 10 on 476. 8 and 10, pause and come back. Okay, guys, here's 8, here's 10. I'm going to move away. I would encourage you to pause at this point. If you got x is 3, y is -1, you don't need to pause. For your 8, if you got x is -3 and y is -9, for 10, you don't need to pause. But if you did not get these answers, and my correct answers are all boxed in, so you can't miss them, I would encourage you to pause and go ahead and see where you went wrong. I solved it step by step. Go ahead and see what went wrong, why you didn't get the answer that I got. In 10, you need to know that I was tricky. Remember, I told you I like to work with positive numbers. I moved the 5 over instead of moving the -2x over. I would have worked with too many negatives. So I used my second equation, moved the 5 over. I had positive numbers. It was so much easier to work. Okay, I'm going to move up. Pause if you need to right now. And if not, here we go. We're going to move into the second part, or the third part, which is elimination. And this is just simple elimination. This is the one that we do like. I'm going to write this 7.3, elimination. This is the one where we eliminate without having to times anything anywhere. We just have to determine, are we going to subtract or are we going to add? I need this to focus. Come on, friend. Here you go. Okay, here it is. 5x minus y equals 8. Negative 5x plus 4y equals negative 17. And for the sake of it, I'm going to use another one just because we can. I'm going to try to find one that, and I'm going to work 15 on 477 because I need you to see the two differences. 15 says 9x minus 2y equals 34. And 5x minus 2y equals 10. Okay, we have two different cases. And the reason I'm doing this is because I want to remind you, the simple elimination is when you have a variable that has the same number in front of it. There's two cases. Opposite signs, positive 5, negative 5, we add because that cancels each other out. Same sign, we subtract. Remember that? So, same number, opposite signs, we add. Same number, same sign, we subtract. Let's start with this one. If we add 5x minus 5x, they go away. Negative y plus 4y gives me 3y. 8 plus negative 17 gives me negative 9. I divide by 3. Y equals negative 3. And I can pick up any of these two equations now and solve it. I'm going to pick the first one. 5x minus negative 3. Please remember that negative is not that negative. So you have a minus and y is negative 3 equals 8. Minus minus becomes plus. 5x plus 3 equals 8. Really? This is, yeah. Minus 3 minus 3. 5x equals 5. I divide the 5 out. Can you still see? Yes, you can. X equals 1. Y equals negative 3. We solved it. So we had a variable that had the same number, different signs. We added to eliminate it. That's the point of it. That's why it's called elimination. Then we add correctly with the signs, and then we end up with y equals negative 3. We substitute that y in any of these two, no matter which one you would have picked, it would have been the same answer. X equals 1. Let's move to the second one. Y has the same coefficient, same sign. We're going to have to subtract. 9 minus 5, 4x. These are gone, equals 34 minus 10, 24. This is actually a nice one. Divide the 4 out. X equals 6. These are the nice elimination ones. Then I'm going to come back and plug in either one I want to. I'm going to use this one because it just has smaller numbers. 5 times 6 minus 2y equals 10. 30 minus 2y equals 10. Minus 30 minus 30. Negative 2y equals negative 20. All I have to do is divide by negative 2. Please remember signs, otherwise it's not going to work for you. A negative divided by a negative is a positive. Y equals 10. X is 6, y is 10. I check with the book, it's correct. Okay, so different signs we add, same side we subtract. We subtract carefully. If this would have been a minus, this would have been a 9 minus minus 5, which would have become a positive. Always pay attention, okay? I'm going to let you take a break, and I need you to work 12, and I need you to work 14. 12, 14. Okay, pause. 12, 14 on 477 and come back. Okay, friends, here are your two problems. I'm going to try to get out of the way as much as I can. The first one was pretty easy. Negative 2y, positive 2y, we added. Here's your answers. The second one is where I want to focus. If you need to, at this point, pause and check your work. Go ahead, pause completely, and then restart, and you can hear my explanation. For the second one, the reason I picked it is because you had the x minus minus 2. That became 3x. If you got the wrong answers here, it's because of this minus minus, okay? X minus minus 2 becomes x plus 2x, which gives you 3x. After that, everything is just a walk in the park. You should have ended up with x equals negative 2 and y equals 2. Let me move out again. If you need to pause, go ahead and pause and check. And then if not, we're going to move on to the next step, which is, oh, I should have not do that. It's okay. I'm going to put 4 and I'm going to put an age elimination. And that is because it's a hard elimination. As in, this is the part where we kind of have to either times only one equation or times both equations to be able to eliminate something. Great news, after this life gets easier. So here we go. X minus 2y equals -7. The second example is 3x minus y equals 4. Let me make sure that I wrote this correctly. Yes, this is the easy type of the harder ones, okay? This is where I only need to times 1. I'm going to go ahead and times the top one by 3, which means I end up with 3x minus 6y equals -21. Remember, this 3 gets distributed everywhere, right? Then I have 3x minus y equals 4. Again, 3x, 3x, same sign, same number. I'm going to minus. This is not a complicated one, but again, science. -6y minus minus y. -6y minus minus y plus -6y plus y, -5y equals -21 minus 4, -25. I divide by that -5 and I get to a beautiful y equals 5. I like that number. You can hear a dog barking probably. And I can take this and plug it anywhere. I'm going to plug it in there because it's an easier equation. I end up with 3x minus 5 equals 4 plus 5 plus 5. 3x equals 9. X equals 3. X is 3. Y is 5. This was the type of problem where you only times one equation. And unfortunately, that's the only example in the book. So we're going to pick another one and work together where we times both equations, because I need you to remember that because it's in your text. Okay, so let me pick one up that I can do easily. I am going to go ahead and work 21. 8x minus 7y. 7y equals -3. This is a y. I just draw it funny. And then 6x minus 5y equals -1. Okay, clearly I can't just time one of the equations. I need to do something different. So in this case, there's two ways to solve it. One would be to remember the least common denominator for 8 and 6 is 24, which means I would times that by 3, I would times that by 4, and get to 24. Let's say you don't remember that. Then the easiest way to do this is to either times x's by each other or do the y's. So if this is a negative, this is a 5, I'm going to times the top one to the 5, that's a 7. I'm going to times the bottom by the 7. So we're just going to cross it. Don't worry about the signs. You don't need to times with the signs. You just need to use the number. Remember, everything is distributed. You are going to get bigger numbers when you do this. If I would have times by 3 and 2, this would have looked a lot nicer. But I want you to remember that you can always just do this in case you forget the least common denominator. So I get 40x minus 35y equals -15. 7 distributed. 42x minus 35y equals -7. And now I have 35, 35, same number, same sign. I'm going to minus. This is gone. 40 minus 42, -2x. 15 minus 7, that's 15 plus 7. -15 plus 7, this becomes a -8. I divide by the -2 out. X equals 4. I'm going to check with the book to make sure my x is correct. Yes, it is. And now I need to pick any of these two. It doesn't matter which one to solve for this. I'm just going to use the smaller numbers. 6 times 4 minus 5y equals -1. 24 minus 5y equals -1. Minus 24 minus 24. -5y equals -25. I divide the -5 out. Y equals 5. And it is correct because I already looked in the book. X is 4, Y is 5. So in this type of problem, you have to times both equations. You can either times by 3 and 4 right here, because their least common denominator is 24. If you forget about that, just don't panic. I could have just as easily times by 6 and by 8. Same thing, same story. I've done this times 6, this equation times 8 from there. You would have solved for x, y first, you would have gotten the same answer. But remember, you can times by crossing them this way. I'm going to let you work some together. I'm going to do an easy one and I'm going to do a hard one. I'm going to let you work 19. And for the sake of it, I'm going to let you work 22. Before you pause, 19, 22. 22, your second equation, if you look in the book, the first equation needs to be rearranged. You have something like 5x equals something y, 3y minus 2. You can't solve it this way. This needs to come here before you do anything, okay? I'm just giving you a hint. This needs to be moved. 1922, pause and come back. Okay, guys, here we go. 1922. 19 was pretty self-explanatory. You times by 2. You minus, as long as you minus correctly, this becomes 15 equals 75. It's 15y equals 75, y equals 5. Plug it in, x equals negative 2. I'm standing here because if you need to pause and check, you can do it right now. You get a clean board without me there, just a shade. For the second one, I already rearranged it. That 3y had to be minus on the other side. So you end up with 5x minus 3y equals negative 2. 3x plus 2y equals 14. This was an easy one. All I had to do is times the top by 2 and the bottom by 3. And I always like to go, remember I told you I like to go for addition because it doesn't mess with signs. Because I had a minus and a plus, I did it that way. The other you could have done it was times by 3 and by 5. Maybe you did. I don't have those answers. But if you did it that way and you didn't get x equals 2 and y equals 4, somewhere the signs got messed up. Okay? Again, let me move one more time. If you need to pause to check, do it. If not, we're about to be done. The last part we're going to do here are the special systems, which we talked about. And we said that either all we did right now were system of equations that had one solution. That's all we did until now. And then you have the system of equations, 7.5, special systems. And there's two of the special systems, one that has no solution and one that has infinite solution. And if you remember, we again talked about this at the end of 7.5 as a subchapter, and I'll give you the page number just in case. On 476, it tells you that there's a way to know the number of solutions. Either one when they intersect, no solution when the lines are parallel, or infinitely solutions if they get on top of each other. That's just how it works. On 460, it tells you again a different way to look at it by slope. If your equations have different slopes, you have one solution. If they have the same slope but different intercepts, so 2x plus 5, 2x minus 2, then those have no solution. And if they have the same slope and the same intercept, then you have infinite solutions. Let's work one of them. Here it is. Negative 2x plus y, negative 2x plus y equals negative 3. And then I have y equals 2x plus 1. There's two ways to solve this. I can just go ahead and substitute all method. And we're going to end up with 0 equaling negative 3. And there's no solution with that. So if I just take this and plug it instead of y, I end up with negative 2x plus 2x plus 1 equals negative 3. Negative 2x plus 2x go away. 1 equals negative 3. Never. No solution. The other way to do it would have been to just move this 2x on the other side and end up with y equals 2x minus 3. There's my equation. And here's the second one. And I can see immediately same slope, different intercepts. No solution. This is the fastest way to solve stuff like this if you remember the rules. If you remember that same slope, different intercept means no solution, you are good to go. Okay, but this is how we do it. I'm going to pick one that has an infinite solution. because I need to know which one has an infinite solution, I can make one up. X, 2x plus y equals 3, 4x plus 2y equals 6. I literally just made it up. It's on your book. So I'm looking at this, and there's two ways to solve it. Again, I can go ahead and in this case do substitution. Minus 2x minus 2x, which means this one becomes y equals negative 2x plus 3. I can take this and plug it in there. 4x plus 2 times negative 2x plus 3 should equal 6. Remember this, you distribute. How do we distribute? We times each one of them. 4x minus 4x plus 6 needs to equal 6. Well, this is 0. 6 equals 6 all the time. Infinite solutions. I end up with a full equality, 6 equals 6. The other way to solve this would have been to again do the slope thing. Let me erase this part and say this is easy to bring it to the, that's why I didn't erase that. M equals y equals mx plus b minus 2x minus 2x. I end up with y equals negative 2x plus 3. That's my first equation. Let's work on this one. Minus 4x minus 4x. 2y equals negative 4x plus 6. I just need y. I divide by 2 everywhere. Y equals negative divided by positive, negative 2x plus 3. What do you notice? Same slope, same intercept, infinite solutions. So either way, I don't care how you solve this type of problems. You can do substitution, elimination, graphing, knowing the slopes. The key is there are cases when you have one solution, most of them are that way. You have some systems that have no solution, and those are whenever you have the same slope and different intercept, those are parallel lines. And there are some cases where you have infinite solutions. That is when you have the same slope and the same intercept, which means the lines get on top of each other. Okay, I'm gonna let you work some alone. We're almost done. I'm trying to figure it out. The answers for this. I'm gonna let you work 25 and 26 on 478. So I'm gonna let you work 25 and 26. Go ahead and pause, come back. I actually have no clue if that has one solution, infinite solutions, or no solution, because the answers are in the back and I can't look for them. So 24, 26, 25, 26. I have a problem. Come back, pause. Okay, guys, we picked the right problems. On 25, you should have negative 4.5 equals 0, no solution. Okay, I just went ahead and took my x and substituted here for x, did the math. The 3y minus 3 gives me 0. I have negative 4.5 needs to equal 0. It never does, so it's no solution. On the second one, all we had to do is do the rearranging. I moved x on the other side. Y equals x plus 8. Y equals x plus 8. Same slope, same intercept, same line. Infinite solutions. Okay, if you need me to move, you can go ahead and pause now and check your first problem. If not, we're moving to 7.6, which is literally mainly calculator. And there's no other way for me to show you this other than once we work it, I actually need to take some pictures. This is system of inequalities. Y is less than negative 2x plus 3. And y is greater than and equal to x minus 3. Please remember, greater than, less than, dotted line. Greater than equal to, less than equal to, continuous line. It will continue test. Okay, so this is just calculator work. Let's remember. I'm gonna go to y equals. I need to clear everything out first. Then I need to go change my signs. Please remember how you do that. I don't remember how each one of you do it now, but I'm confident you do. Negative 2x plus 3. For my second one, I'm going to go ahead and look for greater than or equal to. Here it is. And this is x minus 3. I'm going to go ahead and show you this and let it focus so you can see what needs to point where. If you look at mine, Jonathan, you only have the little triangles in front of y, so just make sure they point in the right direction, because you're going to have equal sign there. And I believe Laura will have an equal sign too. It's just going to have the little things. Ignore my y3. Let me fix it, because that's going to really throw you off. You're going to think that is something and it's not. Okay, there it is. Let's try it again. You should only have two equations. It will focus. Ooh. Here it goes. This is what you're looking for. Zoom 6. And if you remember, we said we only keep the one that is double graphed. This, we're going to estimate a lot of it. So really all I'm going to do is go, this line kind of comes like this, and this line, and it's dotted. Please pay attention. Okay, my first equation, your first line, especially for Jonathan, it matters, is dotted. The second line is kind of continuous. And the only part that I care about is this. Please remember, you have to graph it. Okay? This is it. I'm going to let you pause. We're going to go a little bit over 30 minutes on the video. I'm going to let you pause, and I'm just going to let you go ahead and work 28 and 30. 30 adds a dimension to this. Please remember, x something is always a vertical line. So I'm going to wait help for you. And this is problem 30. The only thing I want to do for you tells you x is less than 2. This is 2. I'm going to write the line. And all my numbers less than 2 are on this side. So once you graph, remember, even if your graph moves that way, you can move past 2. Okay, so 478, 28, and 30, come back. Okay, guys, here we go. I have the two graphs on my phone because I can't show them back to back. So for 28, this is what we're looking for. Let's see if my thing focuses. It should eventually. Here it is. So this is the shaded part we're looking for, right? Make sure you have the same thing. And for the second one, I actually have my calculator that did it for me, and I can show it to you. It is a really funky looking triangle. Once it focuses, do you see that? We're just looking for this little triangle. You can pass that y equals 2 sign. So that's where you are. You should have had a little triangle. I'm hoping that worked out for you. The only thing that I want to look at together before I let you go is that word problem. Although I don't think you're going to need it. I think I took that problem out of your test. But we're going to look at it anyways. Take a second and read it while I write stuff down. Okay. It says you have a $40 gift card to go to the movie theater. A ticket costs $5. Ticket, $5. And then, oh, that's for matinee. And for the ticket in the evening, it's $8. Write and graph a system of inequalities for the numbers of tickets that you can purchase using the gift card. And really, you don't have to do that ever, and I took that out of your test. But here's what you know. You have $40, you want to buy some tickets? Okay. Hello. Hello. Here we go. You just want to buy tickets. So I don't know how many tickets I'm going to buy in the matinee. I'm going to call it X. And I don't know how many tickets I'm going to buy in the evening. I'm going to call it Y. But here's what I know. That 5 times X, the monies that I spend for matinee, plus 8 times Y, the money I'm going to spend for the evening, cannot go over 40. Why? Because that's all I have. I have $40. That's how much money I have. So this is my inequality. The reason I'm asking you to write a system is because this is a real life problem. That means you cannot buy negative matinee numbers, which means X has to be greater than or equal to 0. And you can also not buy negative evening tickets because, again, this is real life 4. So also Y has to be greater than or equal to 0. This is what they're looking for. This is the system. We're not going to bother with it. I just want you to understand when they show you something like this and they say write more equations, because you're going to be like, well, all I have is this. $5 times the morning tickets plus $8 times the evening tickets needs to be less or equal to 40 because that's all I can expend. But because this is a real life problem, it actually constrains you to know that both the morning tickets and the evening tickets have to be positive. You can't buy -5 tickets. And that's what they mean for. And this is it. This is all of your video. Read your instructions for your test. Make sure you don't work what you don't need to work. Good luck. 35 minutes. We did great. See you next week.